Think about yourself for a moment. We all know that the human brain contains two halves. You have the left half, the logical part, and you have the right half, the creative part. Or generally, that's how it goes. These two halves are not completely connected, but they have a converging point somewhere in the middle. They are separate, but they are basically forced to work together to create thought. While I was working on my grocery store traffic video, I had another idea. The human brain is based on neural patterns, which is why it generally ends up relegating certain parts of the brain to certain tasks, even if the brain all looks the same on the outside. AI models mimic these same neural patterns, but with code instead. If the human brain is two halves working to create thoughts, then what if you force two AI models to work together the same way? I actually thought about how this could work, and I figured that the best way to do it would be to try and replicate the human brain. One model would be weighted for logic, analysis, and structure. The other model would be weighted for, creativity, emotion, care, something like that. One of these models would produce the first response and send it over to the other half. The other half would refine the response based on its logic and return it. They would go back and forth, refining the response to their own wants until one of them decides to not change it. The final result would only come out once the models have effectively reconciled on what the response should be. This would naturally be very expensive, and likely only possible in the future with better technology, but it is my thought that this setup would eventually produce responses that sound very human, or at least more natural than any singular AI model does. I expect it would be very unstable at first, but after enough back and forth, it would, theoretically stabilize into a pattern of interaction. The models could get more efficient at working together and naturally end up reducing the friction between them over time. You could even wait for a certain number of passes back and forth to encourage them to resolve it by X amount of refinements. This is obviously just a personal theory of mine, but it might be worth looking in the future. I basically just thought that since we're already simulating neurons with AI models, then perhaps we should simulate the reality of how our brains function. Here's a side note. There's another interesting tidbit of information to also consider. Certain animals, like the octopus, have a form of distributed intelligence. They have neurons throughout their body, which means that you don't really need a brain to formulate thought. What really matters is the pattern of these neural pathways and the way information travels through them. Theoretically, with enough different nodes that contribute to different purposes, you can make an actually intelligent AI model. The biggest issue I've come across is that AI systems are too controlled. All of the whatever parameters they use are too structured. So I started to wonder, what if you made a single node in the AI form its own connections to all the other nodes? It would be very messy, that's true, but with enough time, it should connect to all the different nodes available and form these chains of connections, these patterns, based on whatever information it gets fed. It would be more like growing an AI than creating one. This could create some unusual results, but I think it would be very fun to experiment and see what happens. If I had the resources and the knowledge to create and test AI, I would just do it myself. I'm probably wrong about the technical details. I know I've been wrong about technical details before, and I'm sure I'll be wrong about them again, but I care more about the concept than I do about technicalities. I think that maybe the path to mimicking intelligence is to let it emerge on its own, rather than try to design it. By making models argue back and forth until they resolve something, or by making an AI form its own internal connections, we might end up with something a lot more lifelike than we expect. If our brains start with a single neuron, why not see what happens when you apply it to an AI?